Okay, hi everyone. Welcome back to Information Economics. This is our lecture 7, and again, we will talk about adverse selection problems, in particular screening problems. We will continue our discussion about two-type models by introducing to you the paper Taylor and Xiao 2009. So we will discuss this paper, published in Management Science on 2009, and Management Science is one of the most influential journals in this world. In our field. Okay. The reason that we want to discuss this paper is not only because it is a natural application of the two-type model. It also has the following features for us to discuss it. First is discuss about supply chain coordination. This helps us to review again the idea about efficiency and inefficiency. And then it's rebates and returns contracts. We spent some time to discuss these two contracts in class, and with this paper we will be able to extend our knowledge about them. Finally, in this paper we have this very interesting endogenous adverse selection problem. Unlike the very basic monopoly pricing problem you did last week, in that case, adverse selection problem or information asymmetry are always there. But here, whether you have information asymmetry is determined by the player's action. We're going to see that later. Okay, so that's the reason that we want to study this paper. I will first introduce the problem to you and then set out model. Then we will analyze the centralized case and the decentralized case with different contract formats. So this is a paper discussing demand forecasting. Why do we want to do forecasting? It's because we want to get demand knowledge so that we can mitigate supply-demand mismatch, right? If you cannot estimate the demand well, and your supply and demand have some mismatch, then you have for either the shortage cost or the inventory cost. Both are not so good for you, right? In a supply chain, or if there is a manufacturer, there is a retailer, typically it's the retailer that is doing forecasting. The manufacturer just cannot do that. He's not an expert in markets, he's an expert about production, but how may you ask a manufacturer to do marketing, to do forecasting, right? And because everybody knows that it's the retailer that has this forecasting cost, so the manufacturer may want to provide some incentives for the retailer to somehow do the forecasts, right? As a manufacturer, he may want to compensate the retailer for doing the forecasting. So we were going to study how the forecasting cost affect the supply chain. The manufacturer will want to ask these questions. First, is it always beneficial to induce forecasting? The reason to ask this is certainly because there are multiple effects introduced by forecasting. First, we can reduce supply chain and supply-demand mismatch. That's good. But also, if the retailer does forecasting, she is going to learn something the manufacturer cannot learn. She is going to have information asymmetry. The manufacturer is going to face information asymmetry, right? So, it may be possible that the manufacturer does not want the retailer to do forecasting. Okay? That's something to discuss. So we want to ask, when is inducing forecasting beneficial? And if that's the case, how do we induce forecasting? Regarding how to induce forecasting, definitely we need to discuss contracts, because the manufacturer can only design contracts to induce the agent or the retailer's behavior, right? So we study two kinds of contracts that are related to the forecasting decision. The first one is a rebate contract, in which the manufacturer pays a bonus to the retailer for each sold unit. This is essentially providing a lottery to the retailer, right? And the retailer now has the incentive to know the demand more, so that the retailer can better evaluate how good the rebate is. On the other hand, the manufacturer may offer a return contract that requires the manufacturer to buy back unsold products. In this case, the manufacturer is offering an insurance to the retailer, and now the retailer would be discouraged to do forecasting Because if I have the insurance for all my unsold product, I would become careless about my demand, right? So that's why this discouragement occurs. As a manufacturer, I don't really care about whether the retailer does forecasting or not. What I really care about is which is optimal to me, which gives me more money. I want to ask which contract format is more beneficial to myself. So with all those questions in mind, let's first set up our model, and after the model, we will be able to describe our problem more precisely. We studied a situation with a manufacturer and a retailer. The unit production cost is C, unit retail price is P, nothing else. Without forecasting, the company believes that the random demand follows this CDF f of Fn. Okay, but this is the original situation. In order to get more knowledge about the demand, the retailer may forecast with a forecasting cost K. In that case, the retailer is going to obtain a private signal which may be high or low. With probability lambda, the signal would be high, which means a favorable signal. In this case, the retailer is going to become optimistic about the demand situation. She believes that the market is good, and the updated demand would become a new CDF FH. On the other hand, with another probability, the retailer may observe an unfavorable signal, which we call it L. In that case, we say she is pessimistic, and she believes that the market is bad, and the updated demand function now becomes FL as the CDF. Okay? We say FL is bad and FH is good because we assume FL is always higher than FH, which implies low demand is more likely to occur. Also, our interpretation of the demands is the following. It may be FH, it may be FL, but we don't know it. When we do not know it, we estimate the true demand function by doing this average. Okay, so that's how we interpret FL, FH, and Fn. Technically, we assume capital F is strictly increasing, and Fs bar is the probability for demand to be higher than X. So here, let me provide an example that is not contained in the paper to illustrate the idea of demand forecasting. In this concrete example, demand may be either uniform 0,1 or uniform 0,2, which means the market is either good or bad. Okay, if it's good, then it's uniform 0,2. Otherwise, it's uniform 0,1. We may combine these two and say that the demand is nothing but d of theta, where theta is the upper bound of the uniform distribution. So we know theta is 1 of 2. And then the probability lambda means the firm somehow estimates the probability for theta to be 2 is lambda. Okay? So if we do not know theta, then a firm can only believe that the demand is some kind of combination of these two demand functions. Okay? So what does that mean? We know the demand CDF may be, for example, FL, or it may be FH. And now, because we do not know which one it is, with our estimation lambda, we get a combination of these two functions. The black line is Fn. Okay? We somehow estimate the uninformed demand to be Fn. That's our idea. And then, if the retailer can do forecast, the retailer is going to get theta, and then she is going to know whether it is DH or DL. Okay, we call them she. Yeah, so that's our idea about demand forecasting.